Okay, so as a continuation of our discussion earlier, we are now going to proceed with our idea about the molar mass. So counting atoms or molecules can be very difficult because they are very small. However, you can count the atoms or molecules by weighing them. When you weigh 1 mole in a balance, you get the molar mass, whose unit is grams per mole. So the molar mass can be defined as atomic mass of an element or the molecular mass of a compound in grams. To help us in understanding our idea about the molar mass, let us have the following example. But first, let us identify where can you find the atomic mass number of the element on your periodic table. So it is written as the atomic weight on your periodic table. So as an example, we have nitrogen, whose atomic mass is 14.01. This is expressed in AMU, or atomic mass unit. So it helps to have your periodic table with you. So we have the following examples. For the element carbon, it has an atomic weight of 12 AMU, or 12 atomic mass units. So to get the molar mass, you are just actually going to change the unit. So carbon have 12 grams per mole as its atomic mass. For sodium, you have 23 AMU as its atomic weight. Therefore, its molar mass is 23 grams per mole. For oxygen, you have 16 atomic mass units. Then, its molar mass is 16 grams per mole. Other examples that we have, you have your phosphorus, whose atomic weight is 31 atomic mass units with a molar mass of 31 grams per mole. So you have also the fluorine with 19 as its atomic weight and 19 grams per mole as its molar mass. The same idea goes with your nitrogen, having 14 atomic mass units and 14 grams per mole as its molar mass. It is very easy, right? So with that, let us try this. So identify the molar mass of the following elements. You have iron, magnesium, aluminum, and potassium. Using your periodic table, you can find out that iron has an atomic weight of 55.845. So therefore, it has a molar mass of 55.845 grams per mole. With magnesium, it has 24.305 grams per mole, and aluminum have 26.982 grams per mole, and potassium with 39.098 grams per mole. Now that you have mastered identifying the molar mass of the elements, let us now try to identify the molar mass of the compound. Again, if we go back to our definition, the molecular mass, or also referred to as the molar mass of a compound, is calculated by adding the atomic mass of all the atoms in a molecular formula. So, on this particular portion, we are going to add all the atomic mass of all the atoms present in that particular compound. Such as an example that we have here, we have your ferric oxide, or written as Fe2O3. We have iron, whose atomic weight, or atomic mass rather, is 55.845. So you are going to multiply that by 2 to get 111.69 atomic mass units. While oxygen has 16 atomic mass units, so we are going to multiply that by 3 to get 48. Again, to get the molecular formula, we are going to add the molar mass of each of the elements involved. So 111.69 plus 48 would give us 159.69 grams per mole. So where do the number 2 came from in our ion? So that means that 2 written as a subscript indicates that it has 2 atoms present. So you are just going to multiply that number to the atomic mass of the element. The same way goes with your oxygen, wherein you have 3 atoms in this particular compound. You have 3 times 16 to get your 48. Another example that we have the carbon dioxide. So carbon, with only having 1 atom for this particular compound, we are going to multiply that with the atomic mass unit of carbon, which is 12. And then you have your oxygen. Again, the atomic mass of oxygen is 16. Multiply that by the 2 because we have 2 atoms of oxygen present in our compound. So we have 12 and 32 to give us 44 grams per mole as the molar mass of the carbon dioxide. Again, you have those two to explain. You have your calcium chloride as another compound. So to solve for the molar mass, you have calcium with 40.078 as its atomic weight. So the number of atoms present is 1. So that would give us 40.078 atomic mass units. And then you have your chlorine with 2 atoms. So 1 atom of chlorine weighs 35.446 atomic mass units. Multiply that by 2. So you would get 70.892 atomic mass units. And then add the results for each element. And we have 110.97 grams per mole as the molecular mass or the molar mass of the compound. Easy, right? So let us try this. Identify the molar mass of the following compound. Take note of the number of atoms present in each element. So for number 1, we have 95.197 grams per mole as computed. And then we have 28 grams per mole. We have 342 grams per mole for this particular compound of sugar.